Well, today, everybody, we're going to be doing right triangle trigonometry. This is going to be a quick little review. All right? So let's go over the quick 6 trigonometry words. One of them is sine. One of them is cosine. Then we have cosecant. All right, now, on the graphing calculator, you're going to see sine. That's that. Cosine is abbreviated as so. Tangent. This is the abbreviation for cosecant. Secant. And cotangent. Okay. Now, these are ratios that compare sides of a right triangle. That's what you're going to be doing. All right? So, right now, I'm going to write the sine of theta. So this symbol right here, this is theta. It's a Greek symbol. Represents the measure of an angle. I'm going to highlight this angle, just like so. And you always go from the perspective of whatever angle you're looking at. Okay? By the way, theta could be here, theta could be over here. But this perspective is different than this perspective. So you always go from the perspective of the angle. So if it says find the exact values of the 6 trig ratios, you're going from this perspective. So the very first thing I do is I draw an arrow going across from the angle that they've given me. Which means this side, in relationship to this angle, is called the opposite side. The side that is always directly across from this 90-degree angle, that side is always referred to as the hypotenuse. And the side that is next to this angle is called the adjacent side. The word adjacent means next to. Now the abbreviations we're going to use for the adjacent side are going to be A, D, J. Hypotenuse, I'm going to use H, Y, P. And for opposite, I'm going to use O, P, and P. So the sine of theta, everybody, is always the relationship between the opposite side in relationship to the hypotenuse. The cosine of theta is always the relationship between the adjacent side to the hypotenuse and the tangent of theta is always the relationship between the opposite side in relationship to the adjacent side. So I'm going to highlight what you need to know right here. Sine, cosine, and the tangent. You're halfway there. Cosecant of theta, the cosine of theta, not cosine, secant, and the cotangent. These are always just going to be the inverses or the reciprocals of the ones right next to each other. So the cosecant is the inverse of sine. Alright? So, this cosecant right here is simply the flip, or the inverse of sine. The secant is the inverse of cosine. And the cotangent is the inverse of, or the reciprocal. So, look at these, look at the difference between them. I always do them side by side because it helps kind of my brain recognize the pattern. And that's what I want you to recognize is once you find one, you can find all the others. Now, if we look at our triangle, we have an 8, we have a 3, we don't have the length of this side right here, okay? So right now I'm going to identify 8 as my side C, I'm going to call 3 A, and I'm going to call this side B, all right? So just to make things a little bit clear so we don't have a whole bunch of information up here, I'm just going to clear it out real quick. C, A, and B. Whenever we find the missing side, what do? We don't do a squared plus b squared equals c squared. We do b squared equals c squared minus a squared. So c squared is 64, a squared is 9, b squared is 55, so b is the square root of 55, and you have to keep it that way because you can't simplify the square root of 55 because it only breaks down into what? It only breaks down to a 5 and an 11. You can't simplify that radical, so we keep it as the square root of 55. So right here, everybody, put the square root of 55 for B. We're going from this angle right here. Remember, this is our opposite side, this is our adjacent side, and this is our hypotenuse. But hypotenuse, opposite, and adjacent. Okay. So let's do the 6 trig ratios. You should have them in your journal. I'm going to write the sine of theta. What is my opposite side? 3. What is my hypotenuse? 8. Cosine of theta. What's my adjacent side? Square root of 55. What's my hypotenuse? 8. Tangent. What's my opposite side? What's my adjacent side? Okay. So right now, in case you're wondering what we did, this is my opposite over my hypotenuse. This is my adjacent over my hypotenuse, and this is the opposite side in relationship to the adjacent side. Now, once you have these, it's very easy to do the other ones. Cosecant of theta, just the reciprocal, right? It's going to be 8 over 3. The secant of theta is going to be 8 over the square root of 55. And the cotangent of theta will be the square root of 55 over 3. Now at this point, these are all of our 6 trig ratios. This is all 6 of them. But 6 trig ratios for our problem with this triangle right here. Now only 2 of them are not simplified. Okay? The ones that are not considered to be technically simplified are this one right here and this one right here. One thing we're never allowed to have in the denominator, you're never allowed to have what's called an irrational number in the denominator. So we want to go over how to rationalize the denominator. So right now in your journal, what you're going to do, you're going to write the words rationalize the denominator. So I'm going to give you 2 examples of how to rationalize the denominator. So we're going to start with this one. We're going to go 3 over the square root of 55. We're going to rationalize this one first. And then we're going to go and rationalize the one that has 8 over the square root of 55. Now, this is an irrational number. You can't go to the store and say, could I please have the square root of 55 apples, please? They will look at you funny. Alright? However, if you wanted to make that a rational number, all you have to do is whatever's inside the radical, just multiply the denominator and the numerator by that exact same radical. Radical 55 times radical 55 becomes just the number 55, which goes from irrational to something that is totally rational. The numerator would be 3 times the square root of 55. That's your answer that you would put for the tangent. So the final answer for the tangent of theta is technically 3 radical 55 over 55. This is what's called something that has been simplified correctly. So, fortunately, what does this still have in the denominator? The square root of 55. So I can do the exact same process. And when I do the exact same process, I will still have 55 in the denominator. My numerator will be 8 radical 55. And that right there is my final simplified answer for the secant of theta. The only time I would have to simplify more is if 8 can somehow go into 55, then I can still simplify it more, but I can't. So that right there is my final answer. So your final answers are 3/8, square root of 55 over 8, 3 radical 55 over 55, 8/3, 8 radical 55 over 55, and the square root of 55 over 3. Those are your final answers for the 6 trig ratios for problem 1. Those are the exact same processes you would do for all right triangles. Okay? Wondering why it's so quiet, people are working. First thing we're going to do is we're going to highlight where theta is located. You always figure out which angle you're going from. The next thing you do is from this measure of this angle, draw an arrow going across. What does that arrow always locate? Your opposite side. You should always be able to identify your hypotenuse, because your hypotenuse is always directly across from the 90-degree angle, which means this number 7 would have to be your adjacent side. Now I'm going to write SOHCAHTOA, which you probably have seen before at some point in your life. SOHCAHTOA compares sine, cosine, and tangent. This is sine. This is for cosine. This is for tangent. Sine is opposite over hypotenuse. Cosine is adjacent over hypotenuse. Tangent is opposite over adjacent. So I'm not going to rewrite everything. Well, what do we need to find first? We need to find our hypotenuse. So what did you guys do to find your hypotenuse? You probably used what? Pythagorean theorem, right? A squared plus b squared equals c squared. When you do 7 squared plus 24 squared equals c squared, you got 49 plus 576 equals c squared, which becomes 625, which equals 25. Now, something that you need to be aware of, because some people, if they're watching this video, they're like, dude, that's a Pythagorean triple. You should already know that if you're a teacher. Okay, I do. There are very common Pythagorean triples that you need to know that saves you a lot of time and energy. I would like you guys to write down a certain number. There's a lot of them, but these are the most commonly tested. Write down in your journal Pythagorean triples. Okay? When you first learn the Pythagorean theorem, the very first day, the teacher most likely used Pythagorean triples of a 3, a 4, and a 5. Because 3 squared plus 4 squared equals 5 squared. So I'm going to put 3, 4, 5. 5, that's an A. That's the B. That's the C. This squared plus this squared equals this one. The next most common Pythagorean triple is known as the 5, 12, 13. I see that all over the place in standardized texts. 5, 12, 13. So if I see a 13 and a 5, automatically, without doing any math, I know the other side has to be the 12. Okay? The next most common is the 7, and the 24, and the 25. I simply work all this out because I care about you all. Okay? That's the next most common. The last most common that I typically see is the 8, 15, 17. Now there are others, but these are the most commonly used out of all of them. Okay? There are others. You can actually Google them, and there's like a whole long list of them. There's quite a few, but you'll see most of these on standardized tests. Now, most of you probably realize that if you wanted to, you could multiply all these numbers by a common factor. So a lot of times, you may not see the 3, 4, 5, but you might see the 6, 8, 10. What have I simply done? Taken all these numbers and multiplied it by 2. You might not see the 5, 12, 13, but you might see the 10, 24, 26. Okay? This one, you could see a, 14, 48, and a 50. Here you might see the 16, 30, 34. So these can be scaled up, or they can be scaled down, and it'll still work. Okay? If I took half of all those, all right, it would still work, but they wouldn't be considered a Pythagorean triple because these all have to be integers. So these are the most commonly used right here. I put those in your journal if I were you. All right, so here we go. Sine is the what? Opposite over the hypotenuse. So let's look at ours right here. What is our opposite side? 24. What's our hypotenuse? There we go. If that's 24 over 25, automatically I know this is going to be a 25 over 24 without doing any hard work or labor. The cosine, what's the adjacent side? 7. What's the hypotenuse? 25. Automatically, you don't have to do any hard work. If this is 7 over 25, this has to be 25 over 7. And last but not least, the tangent of theta. Opposite side over my what? Opposite over adjacent. Opposite side is 24. Adjacent is 7. This is the reciprocal. So technically, once you have one, you should be able to solve for all of them. Okay? Because once you have one, you should have the lengths that you need to be able to solve for the missing side and be able to find all 6 trig ratios. Dealing with right triangles. This right here is your final answer for number 2. Okay? On number 3, we actually need to know how to use them. So we're going to do one more example of how to use the trig ratios. Okay? I'll go back. Okay, so we're going to go step by step. Number 3. All right? Here's the very first thing that I want you guys to do. Step number 1. Identify. Spell it correctly. Identify theta, which means identify the measure of the what? Theta. Of the angle that you're going to be working from. That's the first thing. So which angle are we going to be working from in this particular case? 56. Now technically, yes, I know some of you are thinking, well, I don't have to work from 56. Technically, I could do 90 plus 56, all right, take it away from 180, and I could work from here. But they've already given it to us. So we're just going to go from 56. Okay? 56 plus what adds up to 90? 34. So if you wanted to, you could go from this 34-degree angle and do the same problem. But since they've already given us the 56, we're going to start from there. Okay? Step number 2. Identify your opposite side. This is step 2. If you write these steps down, you could actually use these steps over and over again and find all the information that you need. So I'm going to identify your opposite side. You're going to draw an arrow going across. That's step number 2. And you're going to label this side your opposite side. Step 3. Identify your hypotenuse. Which is, we'll put parentheses, which is always across from what? It's across, from the right angle, the 90-degree angle. So see the 90-degree angle right here? We're going to put 90 right there. That's the 90-degree angle. So this side right here has to be my hypotenuse. And that means you can now label your adjacent side. Okay? So x right here would have to be the only side that's left. So when I'm doing it, I never label my adjacent side first. I always start from the angle. I draw an arrow going across, label my opposite side. Oh, there's my hypotenuse because it's always the longest side because it's across from the 90-degree angle, and that leaves me with my adjacent side. So after you identified all these, then you have to ask yourself 2 questions. Here's the only 2 questions you have to ask yourself. What do I have? Well, what do you have? It looks like we have the what? We have the hypotenuse, right? We have the hypotenuse, which is equal to 63.1. What else do I have? I have theta, right? And what is theta equal to? 56 degrees. So you identify, what do I have? And then you ask yourself one last question. What do I need to find? What do I need to find? I need to find x. And what is x equal to? X is equal to my adjacent side. Alright. So here we go. Right now we have, if we write down our trig ratios, which is SO, CA, and TOA, we have what? We have our hypotenuse, and we need to find our adjacent sides. So which one deals with the A and the H? Yeah, this one right here. So that lets you know which trig ratio that you need. So what do you need to look for? You need to look for, do I have this, or this scenario going on? Well, right now we have the A that we need to find. We have the H. So right now, here's what you write down. You write down the cosine of the angle, so the cosine of theta. And theta is equal to 56 degrees, is equal to my adjacent side in relationship to the hypotenuse. Well, what is our adjacent side? Adjacent x. What is our hypotenuse? 63.1. So after you plug everything in, this is what it looks like. The cosine of 56 degrees equals x over 63.1. Put that over a 1. This right here is your ratio, your proportion that you can set up. Once you set up this ratio, all you have to do is cross multiply to solve for x. You get x equals 63.1 times the cosine of 56 degrees. Now that's all well and good, and your calculator will compute that for you exactly as it needs to. However, if you don't do one thing, everything will be messed up. So here's the last thing. Make sure your calculator is in, go ahead, say it, you know you want to, degree mode. That's right, degree mode. So let's say you're just nodding off, you're not really paying attention right now. You might keep your calculator in radian mode, which will totally mess up your answer. So right now, go to your calculator right now. Okay. You hit the mode button right there. See where it says mode? If it's in radian mode, you better switch it to degree mode before you solve this problem. And then you can type in 63.1 times the cosine of 56, because the calculator knows that 56 is the measure of the angle. And then you press enter. And what do you get? 35.3, which is your approximate answer for the length of that sine. That's your approximate answer. 35.3. So right now, what was x approximately equal to? 35.3. And since it didn't say the units that it is, we say 35.3 units. It could be miles, feet, inches, we don't know. It's just in that right triangle. Okay? Your job is to do the rest on your own.